Write down two block system. So in the case of two block system, write down type 1. In the case of two block system, write down type 1. For example, it is a smooth surface. It is a smooth surface. And here we kept a block. Okay, its mass, for example, M2. And here we have another block, its mass M1. And here it is a rough surface. So it is a rough surface. Coefficient of friction is given mu. And here it is applied force. It is applied force. Note on the question. Okay, first of all here, it is a smooth surface and it is a rough surface. If it is a rough surface here, how to find a maximum static frictional force at this rough surface? So what is the maximum static frictional force? So how to find out? Mu into N. You please answer. On this normal force, so on this rough surface, what is the value of normal force acting? M1G or M2G or M1 plus M2 into G?
M2G.
On this rough surface, whose weight is acting?
M1G.
M1G. On this rough surface, only M1 weight is acting. So
Yes.
Fs maximum equal to mu into M1G.
M1G.
And what is the importance of this static frictional force? Okay, so this maximum static frictional force, it always tries to keep the blocks moving together with the same acceleration. This static frictional force, maximum static frictional force, always it tries to keep the blocks to move together with the same acceleration. If they are moving together with the same acceleration, then what is the meaning of relative motion between them? If both are moving together with the same acceleration. First, just imagine that. So imagine that if so, you are keeping two blocks one over another.
Relative motion is zero.
Okay, so
Zero.
correct. For example, we are applying force. Just imagine that. Okay, if you have any books are available, you can do it also. For example, you keep two books one above another. So on the bottom book, on the bottom block, you are giving applied force. If I'm giving a small amount of applied force on the bottom block, they move together or not? If I'm giving a particular value of smaller force, so the two books are moving together with the same acceleration. If we apply a larger force, then they move separately. Okay, so if it is available, you keep two books one above another and you apply force on the bottom book, If I'm giving a smaller force, then the two books, they move together with the same acceleration. If we apply a larger force, then the two books, okay, they move separately with different accelerations. Okay, so that means here up to a particular value of force, so the two books, they move together, and beyond the force, the two books, they move separately or individually with different accelerations. Is the point clear?
Yes, sir.
Yes, sir.
Okay, so first of all here, what we have to find out, up to a particular value of force, okay, the two blocks are moving together, okay, with the same acceleration. Up to a particular, okay, up to a particular value of force, the two blocks, they move together with the same acceleration, and beyond the force, they move separately. Okay, but in this case, the two blocks are moving together with the same acceleration, but who is helping them to move together with the same acceleration?
Frictional force,
Okay,
static
right on.
friction force.
Right on. First point here. Here, Fs maximum. Here, Fs maximum tries to keep the blocks. Fs maximum tries to keep the blocks move together. So here Fs maximum tries to keep the blocks move together with same common acceleration. With same common acceleration. With same common acceleration. That means, so they are moving together with the same acceleration. That means, so what is the relative motion between them? Relative motion is present or no relative motion?
Zero relative motion.
Yeah, right. That means there is no relative motion. There is no relative motion. No relative motion between the blocks. No relative motion between the blocks. Okay, you please answer. If there is no relative motion means, so what type of frictional force will be present? If no relative motion means,
Static friction.
so here static friction is present. Okay, so this is static frictional force. This is static frictional force. Always it tries to keep the blocks M1, M2 move together with the same acceleration, with a common acceleration. So both
So,
are
sir,
together. Please.
so sir, if in this case a person, for example, is standing on block M2 and is observing M1 with respect to M2. So, sir, M1 with respect to M2 will be at rest, no?
At rest position.
Okay, sir. Okay.
So why? Because both are moving with same acceleration in the same direction. So there is no relative motion.
No relative
between.
motion.
Correct. And one more thing here, up to a particular value of applied force, the two blocks, they move together, correct? And beyond the applied force, the two blocks, they move separately with a different acceleration. Okay, so all these points we have to find out. Okay, write down. Next point here, up to a particular value of applied force, here up to a particular value of applied force F, the two blocks M1, M2, the two blocks M1, M2 are moving together, with same acceleration. But who is helping for them to move with the same acceleration?
Fs.
Okay, correct. In brackets, Fs between M1 and M2 is helping. So Fs between M1 and M2 is helping them to move with same acceleration. Okay, so up to a particular value of applied force, the two blocks are moving together with the same acceleration. Beyond this applied force, the two blocks M1, M2 move separately with different accelerations, A1 A2. Move separately with different acceleration A1, A2. Okay, so here, what is the procedure? We are going to discuss the procedure as it is we have to follow for any type of the question. Okay, so now we are going to discuss one type of procedure. Always we have to follow the same procedure. So in this type of questions, okay, write down the procedure. First step, step 1. So always let us assume that in this type of questions, so it is the first assumption we have to make. So if it is one block, so here we have two blocks, applied force is acting on the bottom block, acting on the top block, or we have two applied forces are given, one applied force on the top block, one applied force on the bottom block, whatever. If any type of question, okay, so here it is a rough surface, this also rough surface, we will do all variety of questions, but any variety of question, always we have to start with one assumption. That assumption is, let us assume that both blocks are moving together. Both blocks are moving together with common acceleration. Are moving together with common acceleration. For any type of variety of question, always this is the first assumption we have to make. Okay, let us assume that both blocks are moving together with common acceleration. Then how to find this common acceleration A equal to? How to find this common acceleration? You please answer here.
Applied force upon m1 plus m2.
Perfect. So A equal to F applied. Okay, and one more thing here. So in this case, it is applied force. But here, do we have any frictional force is present?
No, sir.
So I'm taking M1, M2 as a single system. I'm taking M1, M2 as a single system. Why? Because both are moving together. Okay, M1, M2 as a single system. On the single system, what is the only force acting is applied
F
force
applied.
upon sum of the masses. So therefore, acceleration equal to F applied upon M1 plus M2. So it is a common acceleration. Then after, let us draw FBD, free body diagram. So it is the bottommost block M2 and it is the top block M1. And here it is applied force. And what is the assumption we are making? Both are moving together. Both are moving together with the same acceleration. Both are moving together with the same acceleration. Now you please answer. So in the case of M2, it is an applied force, and here it is smooth surface. It is a smooth surface means here there is no frictional force. Okay. So in the case of M1, now what is the driving force? M1 is moving rightward with acceleration A. But in the case of M1, there should be some driving force will be present. Because of driving force, it is moving
Frictional
with
force.
acceleration.
So frictional force.
So that means in the case of M1, what is the direction of frictional force? Forward or backward?
Rightwards.
Okay,
Forward.
perfect. So in the case of M1, frictional force is rightward. Okay, so why? Because in the case of M1, do we have any applied force to bring the block to move rightwards? Do we have any applied force on M1?
Only on M2.
Okay, so here applied force only on M2. But in this case, what we are saying, both blocks are moving together with the same acceleration. So M1 block moving rightwards, M2 block also moving rightwards. But M1 block moving rightwards means someone has to pull it. Someone has to pull it rightwards. But who is pulling here? Frictional force. So if it is a frictional force direction on M1, if it is an action force, then what is the reaction force acting on M2 in what direction?
So could you please repeat?
So in this case, in the case of M1, this frictional force is an action force. Okay. Then on M2, what is the direction of frictional force acting?
Backward.
So
Leftward.
Okay, the backward frictional force where we have to draw on the top surface of M2, on the bottom surface of
Top
M2.
surface.
Top
Bottom
surface.
Okay, at the top
Top
surface.
surface.
and here it is frictional force F. You please answer here. No, this frictional force have same magnitude, different
Equal.
magnitude. Okay,
Equal
same
magnitude.
magnitude. Why? Because one is action force and other one is reaction force. Okay, is it clear? That means on M1, what is the driving force?
Frictional force.
Write down. Next point. Here, on the block M1, the only driving force on the block M1, the only driving force is small f, okay, frictional force. And but what type of frictional force it is? Static or kinetic?
Kinetic. Because
Yeah,
it
other-
is moving.
Static.
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 Perfect. It is
Static.
static
Because
frictional
M1
force.
is in rest.
M1
But
is at rest.
M1 will move now.
M1 is at rest with respect to M2.
Perfect. That is answer. So in this case, M1, M2, how they are moving? M1 and M2, how they are moving together with the same acceleration. Both are moving together with the same acceleration means between them, what is the relative motion?
Zero.
Zero.
So zero relative motion means between them, what type of frictional force is acting?
Static.
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 Static frictional force is acting. So both are moving together with the same acceleration. So both are moving together with the same acceleration means there is no relative motion between M1 and M2. If there is no relative motion, so static frictional force is acting. Okay. So the only driving force is this is static frictional force. So in the case of M1, now you please answer. What is the dynamic equation? In the case of M1, what is the dynamic equation?
Fs minus Fs.
Fs minus Fs. On M1, how many forces
Only
acting?
Fs.
Sorry,
equal to
Only
Fs.
Fs.
F net
Okay.
is
So
equal to
MA is
Fs.
equal to Fs.
So
Fs only.
therefore, resultant force equal to mass into acceleration. Mass is M1 block we are taking into acceleration equal to Fs. But what is the assumption we are making already? They are moving together with the same acceleration. And what is the common acceleration already we have? F
Fm
upon.
upon
Okay.
M1 plus M2.
So therefore, from this equation, what is the value of static frictional force acting between M1 and M2 is M1 into, in the place of acceleration, we are writing F upon M1 plus M2. So this is the static frictional force acting between M1 and M2. Acting between M1 and M2. Now you please answer. So is it clear up to now, all the points? If you have any doubt, let me know. Is it clear? Okay, now you please answer. For example, here we got Fs value. By using this equation, we got Fs. If this Fs value is less than or equal to Fs maximum, okay, this Fs static frictional force between M1 and M2, okay. So here, between M1 and M2, we got Fs. If this Fs value is less than Fs maximum, okay, then how the blocks they move together or they move separately. If the static frictional force is less than or
Move
equal to
together.
maximum,
Move
Together.
together.
right on. If Fs less than or equal to Fs maximum, both blocks move together with common acceleration. And how to find this common acceleration? How to find this common
F
acceleration?
upon M1 plus M2.
F upon M1 plus M2. Completed?
Sir, here M1 plus M2 also means sum of masses, no?
Yes.
Okay, so sir, if there is more than two blocks, then we can also write a summation of masses.
3 masses.
Okay, sir. Okay. Thank you.
So for example, if Fs is greater than Fs maximum, then The
Both
blocks, they
blocks
move
move
together.
separate.
Correct.
Different
Then,
axle.
perfect. Both blocks move separately with different acceleration. If they are moving with different accelerations means what is the relative motion between them? Present, not present.
So present.
Present.
So there is relative motion between them. There is relative motion between them. If there is relative motion between them means, now between them, now what type of frictional force will act?
Kinetic frictional force.
Correct. Kinetic frictional force. Kinetic frictional force acts between them. Kinetic frictional force acts between them. Is it clear, all the points? So they are moving differently, or they are moving separately with the different accelerations. Okay, now we have to find both accelerations. For example, it is a bottom block M2, then after it is a top block M1. And here it is applied force. Then after it is smooth surface. It is smooth surface, so there is no friction. Now in the case of M1 block, so here M1 block moving rightwards with acceleration A1 and M2 block moving rightwards with acceleration A2. But in the case of M1, what is the only driving force present?
FK.
FK, perfect. Kinetic frictional force. What is the direction?
So
Rightward.
rightwards.
Rightwards. It is FK. Then after, in the case of M2, what is the direction of kinetic frictional force?
FK is backwards.
Correct.
Forward.
FK backwards. And what is the value of this FK? FK is nothing but mu into
Mu
N.
into M1G.
Perfect.
Mu K into M1G.
Mu K. So in this case, simply it is given mu in the question. It is given mu means mu S value, mu K value, both are same. Okay.
Okay, sir.
So mu K into M1G, for example, that's up to you. So now in the case of M1 block, what is the dynamic equation? In the case of M1 block, how many driving forces we have? Only Fk. No, resultant force means mass into acceleration. Mass M1, acceleration A1 equal to what is the Fk value is mu K M1 G. So here M1 cancel out. Therefore, acceleration A1 equal to we have mu K into G. Now it is acceleration of the first block M1. In the same way, in the case of M2 block, what is the dynamic equation? In the case of M2 block, what is the dynamic equation? F minus Fk or Fk minus F?
F minus Fk.
F minus Fk. Now resultant force means mass into acceleration. Mass is M2, its acceleration is A2 equal to F minus, and what is the Fk value already we have? Mu K into M1 G. See here, already we have Fk value, mu K into M1 G. Therefore, we are finding acceleration A2. So A2 equal to F minus mu K M1 G upon M2. So these are the different accelerations. Over.
So, sir, the procedure is just to. So, sir, the procedure is just to remove Fnet and then simplify.
Correct. Simply write down F net equation and we can simplify it.
Okay, sir. Okay.
So this all is under step 1, right?
It is step 1 only. So in the same case, step 2, So you please answer. Now I told you already here, up to a particular value of applied force, up to a particular value of applied force, the two blocks, they move together with the same acceleration. Okay, so I want to find out that maximum applied force. Okay, that applied force up to here, for example, I'm getting up to 20 newtons. Up to 20 newtons, they are moving together with the same acceleration. For example, up to 20 newtons, they are moving together with the same acceleration. If it is 21 newtons, then what will be happened?
They
Up
will
to
move with different acceleration.
So that means here F equal to 20 Newton. So up to 20 Newton, they are moving together. Okay. So the 20 Newton. So what is the formula? The formula we have to find out. Okay. You please answer. Now I want to find out the force up to which they are moving together with the same acceleration. Okay. Write down. In step 2, here we have to find the value of applied force F up to which the two blocks M1 M2 move together with same acceleration A equal to F upon M1 plus M2. They move together with the same acceleration F upon M1 plus M2. See here, we have already, they are moving together with the same acceleration means, between the blocks, what type of frictional force we have to consider? Static frictional force or kinetic frictional force?
Static.
So between the blocks, M1 and M2, now we are taking static frictional force. And this static frictional force less than or equal to Fs maximum, correct? So the static frictional force can be having any value from 0 up to Fs maximum. Now you think clearly. For example, if I want to find the maximum force up to which they are moving together. To find this maximum force up to which they are moving together with the same acceleration. So which symbol we have to follow? Fs less than we have to follow, or Fs equal to we have to follow to find the maximum value of applied force up to which they are moving together.
Equal to.
To find maximum value of applied force F up to which they are moving together. Fs equal to Fs maximum. But how to find Fs? To find Fs, we have to consider M1 block or M2 block. What is the easiest one? M1 block. Okay, so already we have Fs value also. What is the Fs value is M1 into, so between the blocks, Fs value already we have, that is M1 into F upon M1 plus M2. So in the place of Fs, we are writing M1 into F upon M1 plus M2. Now this is the value of Fs already we calculated in the first step. And what is the Fs maximum? You please refer the figure. What is the Fs maximum value? Mu into M1g. Now on both sides M1 cancel out. Therefore F equal to, what is the value is mu into M1 plus M2 into g. Now this is the maximum applied force up to which the two blocks they move together. It is a maximum applied force up to which the two blocks are moving together with the same acceleration. Is it clear? Okay, any doubts?
Can you scroll a little up?
Sir, a bit down.
Over? Yeah, write down the question. For example, it is a smooth surface. It is a smooth surface. So this block mass 3 kg and this block mass 2 kg, and it is a rough surface. For this rough surface, mu is given, coefficient of friction 0.3, okay, 0.3, and here applied force. Applied force is, for example, okay, let us do some questions. Some first part. In first part, I'm taking applied force equal to 5 Newton. Okay. In first part of the question, I'm taking applied force equal to 5 Newton. So I told you always, first, what is the assumption we have to make? First of all, if any question is given, first of all, immediately you find out between them, what is the value of Fs maximum? Between them, what is the value of Fs maximum? How to find Fs maximum? Mu into
M1G.
M1G means here 2 kg
2
weight.
into 10.
2 into 10. So that means what is the value? It is 6 newtons. Okay. So in the first question, it is given that applied force is a 5 Newton. So always we have to assume that both blocks are moving together
With common
with common acceleration. So it's the first assumption always we have to make. Both blocks are moving together with a common acceleration. And how to find this common acceleration? A equal to
F upon M1 plus M2.
so F upon M1 plus M2. And here, what is the F value given? 5 Newton. Okay, F value is given 5 Newton. And M1 plus M2 is 5 kg.
5.
Therefore,
1.
acceleration equal to 1 meter per second square. So once we got acceleration, then we have to find a frictional force between them. To find a frictional force between them, what is the easiest method? So by taking 2 kg block or 3 kg block, what is the easiest one? 2 kg. Why? Because in the case of 2 kg block, what is the only driving force present?
Fs. Frictional force.
So if now you consider 2 kg block. Now in the case of 2 kg block, what is the only driving force is frictional force. Therefore, F net equal to Fs. F net means mass into acceleration. And what is the mass here? 2 kg block we are taking. And what is the acceleration we got it? 1 equal to Fs. Therefore, Fs equal to what we got? 3 Newton. Now you please answer. This Fs value is less than Fs maximum or greater than Fs
2
maximum?
Newton, no?
Sir, 2 Newton.
2 Newton. Okay.
Sir, shouldn't it be 2 Newton?
Okay, 2 Newton.
Newton.
So in this case, this Fs value 2 Newton is greater than Fs maximum or less than Fs maximum?
Less than.
Okay, so Fs maximum is 6 Newtons, but here we got only 2 Newtons. So therefore here Fs is less than Fs maximum. If this is the condition, that means they are moving together or differently.
Moving to
Separately.
Separate.
So you please answer. If Fs less than Fs maximum, they are moving
Together.
together. They are
Together.
moving together. So already here we noted the points. If Fs less than or equal to Fs maximum, both are moving together with the same acceleration. So this condition satisfied here. In this question, Fs is less than Fs maximum means therefore both are moving together. Both are moving together with acceleration equal to, what is the value? How much we got it?
1 meter per second.
Okay, 1 meter per second square. And between the blocks, what type of frictional force present? Static or kinetic?
Static frictional
Static.
force.
And what is the value of the static frictional force?
2 newtons.
2 newtons. It is answer. Now we have acceleration of each block, and we have the frictional force between the blocks. So the first part of the question, applied force is given 5 newtons. The second part. So applied force is given
Sir,
10
can you
newtons.
scroll a bit up?
So applied force is given 10 newtons. The same
Thank you, sir.
procedure we have to follow right now. And what is the first assumption we have to make? They are moving together with a common acceleration. So how to find a common acceleration? Equal to F applied upon M1 plus M2. And what is the F applied is 10 Newton upon M1 plus M2. What is the value we have? 5 kg. Therefore, acceleration equal to 2 meter per second square. Then after, to find the frictional force, the bottom block or the top block, which block we have to consider to find the frictional force?
Top block.
Top.
That is 2 kg block. No, why? Because in the case of 2 kg block, what is the only driving force present?
Static frictional force.
Static frictional force. Then you please answer how to find resultant force, mass into acceleration. Mass is a 2 kg and acceleration 2 meter per second square equal to Fs. That implies now we have Fs equal to 4 newtons. Okay, that means here this Fs value is less than Fs maximum or greater than Fs maximum?
Less.
Less.
Less than.
Less.
Less than means what is our conclusion?
They move with common
They
Both
move
acceleration.
together
blocks
with
are
same
moving.
acceleration.
Therefore, both blocks are moving together with. So what is the value of common acceleration? 2 meter per second square. And what is the frictional force? First, what is the nature of frictional force? Static or kinetic?
Static.
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 And what is the magnitude? We got it.
4.
4.
4 Newton.
Already we got it now. Over.
So 1 minute, please.
So can you please show the diagram once?
You refer your book now.
Thank you, sir.
You try this question, third part, and let me know the final answer. Applied force equal to 15 Newton. You try, let me know the final answer. What is the acceleration? They are moving together or separately. You do everything. If applied force equal to 15 Newton. The first assumption is they are moving. Let us assume that both blocks are moving together with the same acceleration. So that is the first assumption. Then you find the common acceleration. How to find the common acceleration? F upon M1 plus M2. So 15 Newton upon M1 plus M2 is 5 kg. And this is equal to 3 meter per second square. Now you
So
consider.
they're moving with same acceleration.
Same acceleration.
with 6 newtons.
Perfect.
Magnitude of friction force 6 Newton.
So in the case of 2 kg, what is the dynamic equation? That is only Fs. Resultant force means mass into acceleration. So equal to Fs. Perfect. So here Fs equal to 6 Newton. That means here Fs equal to Fs maximum. Fs equal to Fs maximum. That means they are moving together or separately?
Together.
Together.
Moving together.
So simply here they are moving together. They are moving together with, so what common acceleration? 3 meter per second square. And what is the nature of frictional force? Static or kinetic? They are moving together. Static.
Okay.
And what is the magnitude?
6 newtons.
6 Newton. Done?
So, 1 minute.
Now fourth part of the question. Applied force equal to 20 newtons.
So they are moving
Okay.
separately. Acceleration 4 meter per second square.
They are moving separately, then how common acceleration you are saying?
Oh,
Okay.
no.
Okay, so generally here we don't know, for example, straight away if the question is given 20 Newton. So you start from the beginning part. Let us assume that both blocks are moving together.
Sir,
Please.
if we are given like this multiple questions, then why can't we just find the F maximum first and then every
That also one method.
Okay.
So let us assume that both blocks are moving together with a common acceleration. So how to find the common acceleration is F upon m1 plus m2. And what is the F value is 20 newtons, and apply, so m1 plus m2 is 5 kg. Therefore, we are getting 4 meter per second squared. Okay. Then you consider 2 kg block, the top one, write down dynamic equation. So here assumption is both are moving together. So what type of frictional force is? Static. Resultant force means mass into acceleration. Mass 2 kg, acceleration 4 equal to Fs. That means here we are getting Fs equal to 8 newtons. Now this Fs value less than or equal to Fs maximum or greater than Fs maximum? Greater than Fs maximum. If this is the condition, so what is the conclusion here? They are moving together or separately?
Separately.
Separately.
Therefore, both are moving.
Sir, can you show the starting point?
Then,
So
both are moving separately means you draw FBD. So for example, here it is the bottommost block, 3 kg, and it is the top block, 2 kg, and here applied force 20 newtons. And for example, here it is moving with acceleration A1, it is moving with acceleration A2. Now in the case of 2 kg block, what is the only driving force?
F kinetic.
The friction.
F kinetic.
kinetic.
Then on 3 kg block, what is the direction of kinetic frictional force? Backwards. Okay, then you consider 2 kg block. And one more thing here, how to find Fk first of all? How to find Fk? Mu k into n, correct. And what is the mu k value is given?
0.3.
0.3. And we are finding this kinetic frictional force. Okay, so between the surfaces, kinetic frictional force. Okay, that means on this rough surface,
N equals
whose weight is-
m1g.
so whose weight is acting? 2 kg.
M1g.
weight. So that means 20 Newton or 30 Newton? 20. Therefore, it is nothing but 6 newtons. Now you consider 2 kg block, write down dynamic equation, that is only Fk, and this Fk value is 6 newtons. Therefore, resultant force means mass into acceleration. So mass is a 2 kg block, its acceleration is A1 equal to 6 newtons. Therefore, A1 equal to, we have 3 meter per second square. In the same way, in the case of 3 kg block, what is a dynamic equation?
F
20.
minus Fk.
Correct, F minus Fk. So 20 minus Fk. Resultant force means mass 3 kg, acceleration A2 equal to 20 minus, what is the Fk value? We have already 6. Therefore, A2 equal to, we get 14 upon 3. meter per second square. Over.
Sir, if it is
Sir, please wait.
Sir, can you scroll up to the starting part of D question?
B question. So it's the part B. Done.
Sir, could you show the D question?
D part.
Yes.
Now you write down homework question, same model.
Could you scroll a little up?
Yes, sir, please.
Sir, a bit more.
Completed. Yeah, right down. Homework question, first one. For example, here it is a smooth surface. This block mass 5 kg and this block mass 3 kg. So it is rough surface. For this rough surface, mu is given 0.2, applied force 8 newtons. Okay, same process you follow. First of all, how to begin with the assumption, and what is the assumption? They are moving
Both
together.
in same acceleration.
Okay. So you find out F value, that F value is less than F maximum or greater than F maximum. Accordingly, you proceed. Okay. Write down second homework question. For example, here it is a smooth surface. It is a block 4 kg and this block 3 kg, and it is rough surface. Mu is given 0.15 and here applied force 10 Newton. Completed. And one more homework question, third one. So it is smooth surface, and here this mass of the block 4 kg and this mass of the block 3 kg. It is a rough surface. Mu is given 0.14, applied force 12 Newton.
Sir, in all these cases, we have to find Fs maximum and Fs, no?
So in all cases,
Okay,
we have
sir.
to find how much frictional force acting between them and what is the acceleration of each block. Okay. Done.
So could you repeat what you have to find?
In all three cases, we have to find how much frictional force acting between them and what is the acceleration of each block. Note down. In all questions, find frictional force between the blocks and to find acceleration of each block. Find the acceleration of each block.
Sir, can you show the third one?
Sir, can you show question?
Which question, man? This is the question.
Yes, sir.
They don't type 2. No, it is a type 1.
Sir,
Type 1 means, please.
Sir, just wait over there, just 1 second. Thank you, sir.
So in type 1, now here I'm taking, it is a smooth surface and applied force acting on the bottom block. So it's a type 1. Next is type 2. Write down type 2. Same thing here, it is a smooth surface. And here it is a block, mass M2. This block, mass M1. And here it is a rough surface. For this rough surface, mu is the coefficient of friction. Now applied force acting on the top one. No, it is an applied force. And same process we have to follow. Let us assume that both blocks are moving together with same acceleration. Both are moving together with the same acceleration. So how to find the same acceleration? A equal to. So both are moving together with the same acceleration. So you take, so M1 and M2S is single block. M1, M2S is single block. If it is single block, so here do we have any frictional force? If M1, M2 is a single block, here we have any frictional force. That means on this single block, what is the net force applied? On this single block, what is net force applied? F upon sum of the masses M1 plus M2. So first, the assumption is both are moving together with the same acceleration. The acceleration is F upon M1 plus M2. Now you please answer. So here, now between the blocks, what is the value of Fs maximum? Between the blocks, what is the value of Fs maximum? Mu into
M1G.
mu M1G. And both are moving together with the same acceleration, means there is relative motion, there is no relative motion.
No relative motion.
So here, there is no relative motion, between the blocks. That means, so which friction is acting? Static friction, kinetic friction?
Static frictional force.
So Fs acts between them. Fs acts between them. Now let us draw FDD. So here it is the bottommost block M2. Now in the case of M2, this bottom surface is a smooth surface, and here it is M1 block. Now applied force acting, and both are moving together with the same acceleration. Both are moving together, okay, with the same acceleration. So in the case, so now here, on which block force acting? On M1 block, on M2 block? On M1 block?
M1.
applied force. Now in this case, so M2 block moving rightwards. M2 block moving rightwards means on M2 block, what is the driving force?
Frictional force
Frictional.
actually acting forward.
Correct. And what type of frictional force?
Static.
Static. Static forward direction, rightward direction. So then on M1, what is the direction of static frictional force?
Backward.
On M1, backwards, leftwards. Now to find this Fs, what is the easiest one? By taking M2
M2.
block, it is the easier, correct? Now you take M2. In the case of M2 block, you write down dynamic equation. What is the dynamic equation? What is the only driving force acting on it? Fs. Okay, then after, how to find resultant force, mass into acceleration? Mass is M2 and already we have common acceleration, that is F upon M1 plus M2. So in the place of acceleration, F upon M1 plus M2 equal to Fs. That implies Fs equal to M2F upon M1 plus M2. So finally here, this Fs is acting between M2 and the ground or between M1 and M2.
M1 and M2.
So it is acting.
Sir, here ground is smooth, no?
Correct. This frictional
Okay,
force
sir.
acting between M1 and M2. Now what is the conclusion here? If this Fs less than or equal to F maximum, this Fs less than or equal to F maximum, how they move?
Equal
Together.
acceleration.
If Fs
Together.
greater than Fs maximum,
Independently.
correct, right on. If Fs less than or equal to Fs maximum, they move together with common acceleration. They move together with a common acceleration. So how to find this common acceleration? Common acceleration equal to
F upon
F
M1
upon
plus M2.
M1 plus M2. Over?
Yes, sir.
Sir, wait.
Sir, 1 minute.
Okay.
Sir,
Please.
can you show the starting of this? Thank you, sir.
So till now, type 1 and type 2 are similar, right? There's
Similar means in type 1, the force acting on the bottom block. In type 2, the force acting on the top block. Okay, if any type of question is given, the same procedure we have to follow. The first assumption, they are moving together, find acceleration, find the friction, then do comparison. F less than or equal to F maximum or greater than F maximum. For any type of question, the same procedure we follow. Okay.
okay, sir. Yes, sir. Yes.
If Fs greater than Fs maximum, they move separately with different accelerations. A1, A2. Now we have to find A1 and we have to find A2. And in this case, so what type of frictional force acts between them? Static or kinetic?
Kinetic.
Why kinetic? There is a relative motion between them or there is no relative
There is
motion?
relative motion.
It is relative.
Here, there is relative motion between them. So Fk, kinetic frictional force, acts between them. But how to find this kinetic frictional force? Mu k into n. And what is a normal force? M1g or M2g or M1G? Perfect. Mu k into n, that normal force is M1g. So here they are moving separately with the different accelerations, A1 and A2. Now we have to find A1 value and we have to find.
Sir, here nu s and nu k are equal, no?
For example, in the questions, in the question, if mu s and mu k are given differently, then accordingly we have to follow. Okay.
Okay, sir.
So you draw FBD. It is M2 block and M1 block. It is smooth surface, and M1 block moving with acceleration A1 and M2 block moving with acceleration A2. On M1 block, we have applied force. In the case of M2 block, what is the driving force? In the case of M2 block, driving force, Fk, frictional force. In the case of M1, frictional force, leftward direction. And we have already Fk value. Okay. So first of all, you take M1 block. In the case of M1 block, what is the dynamic equation is applied force F minus Fk. Resultant force means mass into acceleration. Mass M1, acceleration A1 equal to F applied minus Fk. And what is the Fk value we have already? That is mu k M1g. Mu k M1g. That implies acceleration A1 equal to F minus mu k M1g whole upon M1. Now it is acceleration of the block M1. In the same way, now you take M2 block, write down, it's a dynamic equation. In the case of M2 block, the only driving force is Fk, frictional force. Resultant force means mass into acceleration. Mass M2 block, its acceleration A2 equal to Fk. We have the value already, that is mu k M1g. Now we are finding acceleration A2. Therefore, A2 acceleration equal to, we have mu k M1g upon M2. Now these are the acceleration of both blocks M1 and M2.
Sir, we don't have to remember formula, we have to remember procedure, no?
Just see the procedure.
Okay, sir, okay.
Done. So same case. Now we have to find till what maximum applied force up to which they move together. Okay, here it is applied force. So till what applied force? Okay, so till what applied force, both blocks they move together. Okay, this applied force we have to find. Right down. Now we have to find maximum value of applied force, maximum value of applied force F, up to which they move together with common acceleration. They move together with common acceleration. Now we are finding the maximum value of applied force up to which they are moving together with a common acceleration. So they are moving together with a common acceleration means, so which friction, static or kinetic?
Static.
Static. But in this case, this is static frictional force we are finding maximum value of applied force. Then Fs, which condition we have to follow?
Equal to Fs max.
Equal to
Perfect.
Fs maximum.
Fs equal to Fs maximum. And what is the Fs value already? You please refer to the previous. What is the Fs value already here?
So M2F upon
M2F
M1
upon
plus M2.
M1 plus M2. So this Fs equal to, in the place of Fs, we are writing M2 F upon M1 plus M2. But in the place of F, what we are finding? Maximum. Okay. So we are finding maximum applied force up to which they are moving together with a common acceleration. That means Fs equal to Fs maximum. So it is a Fs value already equal to, what is the value of Fs maximum? You please answer. Fs maximum. Mu s into
M1G.
M1G. Therefore, from this equation, what is the value of F maximum equal to M1 plus M2 into mu s M1G upon M2. Correct? So here it is the maximum applied force up to which they move together. They move together. So you please answer. If it is a maximum applied force up to which they are moving together, that means here they have different acceleration or common acceleration.
Common acceleration.
Then how to find the maximum value of common acceleration? How to find the maximum value of common acceleration? To find maximum value of common acceleration means this maximum
F
applied
max.
force. Correct. Right down. Common acceleration. Common acceleration becomes maximum. Common acceleration becomes maximum when applied force is, what is the value? Applied force is
F maximum.
F maximum. Applied force is F maximum. So therefore, we are finding maximum common acceleration equal to find maximum acceleration, we have to consider maximum applied
F max
force.
upon sum of masses.
Sum of masses M1 plus M2. And we have already F maximum value. We have already F maximum value. Okay. So therefore, A maximum equal to maximum common acceleration. So it is a maximum common acceleration. So we have already F maximum value upon M1 plus M2, then M1 plus M2, M1 plus M2 cancel out, correct? Then what is the value we get finally? Mu is M1G upon M2. It is maximum common acceleration. So it is theoretical part. Now let us practice some questions.
Sir, we have to remember this formula.
No.
Okay, only procedure, no.
Just see the procedure.
Okay, sir. Okay.
Sir, this maximum common acceleration formula we can apply for the previous type as well.
Same. In type 1 also we can apply it.
Okay, sir.
In type 1 also, see here, in theory part, write down if you have any space. So it is the maximum applied force, correct? It is the maximum applied force. Maximum applied force up to which they move together. Maximum applied force up to which they move together. Then how to find the maximum common acceleration? Okay, if you have any space in the type 1, so please note down that also. Now I want to find maximum common acceleration. To find a maximum common acceleration, we have to consider maximum applied force up to which they move together. Upon in denominator, sum of the masses m1 plus m2. Therefore, maximum common acceleration.
So it's only mu g, right?
Correct. So here it is F maximum value already, dividing with m1 plus m2, then m1 plus m2, m1 plus m2 cancel out. Therefore, maximum common acceleration is mu g.
And this is for type 1 or type 2?
It is for type 1. In type 1 theoretical part, see last point. In last point, write down here. Okay. Note it down. Completed.
So 1 minute, please.
Done, sir.
In
Sir,
type
can
1,
you scroll down?
okay, in type 1, before first question, you please make, okay, note it down, these points.
Sir,
Please.
before writing this, you found the formula of acceleration max common. No?
In type 1, type 2, what you are saying? In type 2, it's a maximum common acceleration, type 2. Now this equation, when it is applicable, when applied force acting on the bottom block, acting on the top block.
Top block.
Top block. Okay. Write down the question.
Could you explain again how you got mu g?
That is in type 1. This one. It is in type 1, correct?
Yes.
We have already F maximum value. F maximum value upon m1 plus m2. Okay, m1 plus m2 cancel out. Okay.
Got it. Thank you.
Yeah, write down. Now in type 2, write down first question. Okay, same thing. I will do 1 or 2 questions. Rest of the questions homework. It is a smooth surface.
Sir, just for 1 second, can you show acceleration max type 2 formula? Just 1 second. Yes, sir. Okay, thank you.
So this block mass 4 kg. And here, this block mass 2 kg. It is rough surface. Mu is given 0.16. It is applied force. It is given 8 newtons. Applied force 8 newtons. So once mu is given, immediately you find out Fs maximum. You find out Fs maximum. So between the blocks, now how to find Fs maximum? Mu into normal force. Mu value 0.16. What is the normal force? 2 kg weight or 4 kg weight? What we have to consider?
2 kg weight.
That means 20 newtons. That is equal to 3.2 newtons. And what is the first assumption? Assume that
Both blocks are moving together.
correct. Both blocks are moving together. Both blocks are moving together with common acceleration. With common acceleration. So how to find this common acceleration? F applied upon sum of the masses. F applied upon sum of the masses. And what is the applied force over here? 8 Newton. Sum of the masses 6 kg. Therefore, this acceleration is 4 by 3. 4 upon 3 meter per second square. Now they are moving together means what type of frictional force is present? Static or kinetic?
Static frictional force.
So static frictional force is present between them. So how to find this static frictional force? 2 kg block we have to consider or 4 kg block we have to consider to find Fs, static frictional force. What is the easiest one?
4 kg.
4 kg block.
Why? Because in the case of 4 kg block, what is the only driving force is
Fs.
Fs. Okay. So you consider 4 kg block. In the case of 4 kg block, the only driving force is Fs. So how to find resultant force? Mass into acceleration. Mass 4 kg and acceleration already we have 4 by 3 equal to Fs. That implies Fs equal to we have 16 upon 3. So that means Fs equal to 16 upon 3 means roughly what is the value? 5.33. Okay. Now this Fs value is less than or equal to Fs maximum or greater than Fs maximum? Fs maximum 3.
Greater.
Okay, so here
Body will move separately.
perfect. Here Fs is greater than Fs maximum. That means blocks move separately with different accelerations. If they are moving with different accelerations, so what type of frictional force acting between them? Static or kinetic?
Kinetic.
Kinetic. So kinetic frictional force acts between them. Kinetic frictional force acts between them. Now they are moving separately with a different acceleration. So both A1, A2 we have to find out. So here it is 2 kg block. Then after it is 4 kg block. In the case of 4 kg block, the bottom surface is smooth. On 2 kg block, so here 2 kg block, for example, moving with acceleration A1, and 4 kg block, for example, moving with acceleration A2. So both A1, A2 we have to find out. In the case of 2 kg block, applied force is given. This applied force is 8 newtons. Therefore, you please answer on 4 kg block. On 4 kg block, what is the direction of kinetic frictional force? Rightward or leftward?
Right.
Rightward.
So it is kinetic frictional force. In the case of 2 kg block, kinetic frictional force leftward. And how to find this kinetic frictional force? The basic is mu k into n. And mu k, mu s both are same, that is 0.16. And what is the normal force? 2 kg weight or 4 kg weight?
2 kg.
2 kg weight means 20. So that is equal to 3.2. 3.2 newtons. So how to find A1 and A2? You please answer. You take
equation.
Correct. You take 2 kg block, write down dynamic equation. In the case of 2 kg block, what is the dynamic equation? 8 minus Fk or Fk minus 8?
8 minus Fk.
8 minus Fk.
8 minus Fk. Resultant force means mass into acceleration. Here mass is a 2 kg block and we are finding its acceleration A1 equal to 8 minus, what is the Fk value? Already we have 3.2. Therefore 2A1 equal to, so 8 minus 3.2. So what is the value is 4.8.
2.4.
So therefore A1 equal to 2.4. 2.4 meter per second square. In the same way, so here 4 kg block. In the case of 4 kg block, what is the dynamic equation? What is the only driving force acting on it? In the case of 4 kg block, only Fk.
Kinetic force.
Okay, kinetic frictional force, correct. Now resultant force means mass into acceleration. So we are taking 4 kg block, so that is the mass. And we are finding its acceleration A2. And what is the kinetic frictional force? 3.2. Therefore A2 equal to
0.8.
0.8. 0.8 meter per second square. Therefore, in this question, now we have frictional force acting between the blocks, we got it. Then after, and we have acceleration of each block. So this is the question, finding frictional force between the blocks and acceleration of each block. Is the method clear?
Yes, sir.
Okay, then write down homework questions.
Sir, for one
please.
second, could you scroll up to the start of this question? Just for a second. Okay, sir, got it. Thank you.
Write down homework question. First question, it is smooth surface. So mass of the block 5 kg, and here mass of the block 2 kg, and it is a rough surface. For this rough surface, mu is given 0.16, and here applied force 4 newtons. So we have to find frictional force. So I don't know which frictional force, that is static or kinetic. Okay, that also you have to find out. Okay, find the frictional force acting between the blocks and find acceleration of each block. Find acceleration of each block. So once mu is given, immediately in the first step, you find out Fs maximum. Okay. How to find Fs maximum here? Mu into normal force. So 0.16 into what is the normal force? 20 Newton or 15 Newton? Whose weight we have to consider?
20.
20 Newton.
So therefore Fs maximum is 3.2 newtons. Then after, you know, the assumption they are moving together. Now see the condition, which condition satisfies, accordingly you do it. Okay.
So could you scroll up for 1 minute?
This one, previous question.
Yes, sir. Thank you. Done, sir.
Okay. Now write down second homework question. So it is a smooth surface. And here we get, yes, homework question. 4 kg block. And it is 2 kg block. Rough surface. So here, mu s is given 0.5 and mu k is given 0.4. And this applied force 9 newtons. Same question, we have to find the frictional force and we have to find acceleration of each block. But here first we have to find out Fs maximum. To find Fs maximum, so we have to consider mu s value or mu k value.
Mu s.
Mu s value.
Mu s into n. And what is the mu s value is 0.5. Normal force means whose weight we have to consider 2 kg,
2 kg
weight or
2 kg.
so 20 newtons. Therefore, it is nothing but 10 newtons. Okay, so will you do it, this question as a whole?
Yes, sir.
Okay.
Sir.
Same thing, we have to find the frictional force acting between the blocks and we have to find the acceleration of each block. Okay. Next.
Sir, can you please show second question?
Okay.
Thank you.
Write down third question, some difficulty one. For example, it is a smooth surface.
This is homework.
No, we will do it.
Okay.
So this block, for example, M1, and this block for example, M2, and here it is a rough surface. Coefficient of friction is given mu. On this block, applied force is given K into T. T means the time. K into T. K into T. Draw acceleration versus time graph of each block. So we have to draw acceleration versus time graph of each block. You please answer, in this case, this applied force is a constant applied force or the variable applied force?
Variable.
Variable applied force. Okay, whatever the question, so the same procedure we have to follow. If mu is given, first I told you to find out Fs maximum. Okay, so first let us find out Fs maximum. How to find Fs maximum is mu into n. Mu into, so n means M1 block weight or M2 block weight?
M2 block.
M2 block. So therefore Fs maximum equal to mu into, in the place of n, M2G. And what is the first assumption we have to make?
Move with same acceleration.
Consider both blocks move together. Both blocks move together with common acceleration. Consider both blocks moving together with the common acceleration. You please answer. If this is the case, they are moving together with the common acceleration means, so which frictional force is present? Static or kinetic. So static frictional force acts between them. Static frictional force acts between them. Now this static frictional force, so they are moving together with the common acceleration means Fs less than or equal to Fs maximum or Fs greater than Fs maximum.
Less than or equal to.
So Fs less than or equal to Fs maximum. Now to find this Fs value, you think logically, no need to write every time. To find Fs value, now which block we have to consider?
M2.
M2 block or M1 block? To find F value, what is the easiest one?
Sorry,
M1.
M1 block. Okay. So to find Fs, we have to consider M1 block. Why? Because in the case of M1 block, what is the only driving force acting is?
Static.
In the case of M, okay, correct. In the case of M1, the only driving force static. So according to M1 block, in the place of Fs, what we have to write? Mass into
acceleration.
What is the common acceleration? So how to find the common acceleration? You please answer.
Force applied upon
together
total mass.
So force applied upon total mass. But what is the applied force?
8
What is the applied
KT?
KT upon M1
M1 plus M2.
Okay, so it is a common acceleration. But to find Fs, the easiest method is M1 block. Why? Because in the case of M1 block, the only
one driving force,
that is static frictional force. So therefore, this static frictional force is mass into acceleration. And what is the acceleration we have already? KT upon M1 plus M2. Mass into acceleration. Less than or equal to, what is the Fs maximum already we have? Mu into M2G, correct? Therefore, from this equation, what is the value of T? T value less than or equal to mu M2G into M1 plus M2 upon M1K. Okay, in this case, for example, starting from T equal to 0, up to a particular time, the two blocks, they move together, correct? Up to a particular time, the two blocks, they move together, and beyond the time, they move separately. Is it clear? If t value is increasing from 0, if t equal to 0, t equal to 1 second, t equal to 2 seconds, so up to a particular time, the two blocks, they move together. Okay, you please answer. Up to what time the two blocks, they move together? To find the time.
Max.
So
T
which
maximum.
condition we have to follow?
Equal to.
Equal to. Consider the time, for example, I'm taking t naught. Consider the time t naught up to which the two blocks are moving together. The two blocks are moving together with common acceleration, a equal to kt upon m1 plus m2. So to find the time t naught up to which, so to find this t naught, so fs equal to fs maximum or fs less than fs maximum, which condition we have to follow?
Equal to fs maximum.
So fs equal to fs maximum. And what is the fs value already here? M1 into, in the place of fs, I'm writing M1 into kt upon M1 plus M2 equal to, what is the fs maximum value already we have? Mu into M2G. M1G or M2G?
M2G.
M2G. And this time is a t naught. So up to the time t naught, so here they are moving together with a common acceleration. So therefore fs equal to f maximum. Now we are finding this t naught value. Therefore t naught equal to what we get? Mu M2G into M1 plus M2 whole upon M1K. So up to this time, they move together with a common acceleration. So now I wanted to draw the graph. It is time and it is acceleration. For example, here up to the time t naught. Up to the time t naught, how they are moving? They are moving together.
Common acceleration.
So what is the common acceleration here?
So kt upon m1 plus m2.
So in this case, up to the time t naught, they are moving together. They are moving together means, so in the case of first block or second block, they have same acceleration. So what is the nature of the graph? Straight line or the curve?
Straight line.
How you come to know straight line?
Sir, because of
it's
t
common.
naught, both the
This
acceleration are.
equation. So here, what is the common acceleration? Common acceleration equal to, the formula is kt upon m1 plus m2. So here, this acceleration, okay, acceleration value, we are taking on y-axis, acceleration value, we are taking on y-axis, and time value, we are taking on x-axis. Therefore, it is in the form of y equal to mx. So here, what is the slope is? Slope value k upon m1 plus m2. It is a slope. So y equal to mx means nature of the graph is a straight line or the curve. Straight line passes through origin, not passing through origin. Y equal to mx means
Not passing.
No, that's not possible.
then what about y equal to mx plus c? Don't you know till now the equation of straight lines? Y equal to mx.
Equal to mx plus c.
Y equal to mx means passes through origin, not passing through origin.
So does not pass through origin.
Then what about y equal to mx plus c?
Does not pass.
And both are not passing through origin.
So y is equal to mx passes through the
Passes through origin and mx plus c does not pass.
Passes through the origin.
Passes through origin.
So you are the JE people till now you don't know straight line equations. So y equal to mx means nature of the graph is a straight line which passes through origin.
So y equal to mx.
So up to t0 time, they are moving together with a common acceleration. So common acceleration kt upon m1 plus m2, and acceleration taken on y-axis, time taken on x-axis. It is in the form of y equal to mx. The nature of the graph straight line. Y equal to mx means passing through origin.
Yes, sir.
Okay, so here it is
Sir,
a straight
because
line.
y-intercept is 0, that is why.
Correct. So up to t0 time, they have common acceleration. So common acceleration means a1 equal to a2, correct? Up to t0 time, they have common acceleration. But exactly at t equal to t0, what is the value of common acceleration? You refer this equation exactly at t equal to t0. What is the common acceleration?
kt upon m1
M1 plus
And what is the t value we are taking? Exactly at the time t0. So k t0 upon m1 plus m2. Okay, so they move together up to the time t0. So exactly at the time t equal to t0, the maximum common acceleration is kt0 upon m1 plus m2. I have one more question. What is the slope of this straight line?
k
What
upon
is
m1 plus m2.
K upon m1 plus m2. Is it clear up to now? Any doubts?
No, sir.
Then so, but if t greater than t0, then what will be happened? T greater than t0. If time t greater than t0, they move together or they move separately?
So separately.
So they move separately with different accelerations, a1, a2. Now same thing, now we have to find a1 value and we have to find the a2 value. Now they are moving together, they are moving separately means there is relative motion between them or no relative motion between them.
Relative motion
Is there?
So there is relative motion between them. If relative motion between them means, so which frictional force, static or kinetic?
kinetic frictional force.
Kinetic frictional force. Kinetic frictional force acts between them. And what is the value of this kinetic frictional force? Equal to mu into n. So mu into, and what is the n value here? M1g or M2g?
M2g.
M2g. So here n value is M2g. Okay, so let us draw FBD, free body diagram of each block. It is M1 block. In the case of M1 block, the bottom surface is a smooth, and it is M2 block. So here M1 is moving with acceleration a1 and M2 is moving with acceleration a2. In the case of M2, we have applied force. This applied force is given K into T. And what is the T value here? Less than T0 or greater than T0?
Greater than T0.
Greater than T0. In the case of M1 block, what is the only driving force acting?
Frictional force.
And what is the direction of frictional force? In the case of in M1 block, frictional force rightward. And in the case of M2 block, frictional force leftward. So here I'm taking M1 block. Now in the case of M1 block, what is the dynamic equation? Resultant force equal to? What is the only force? Fk. Now resultant force means mass into acceleration. Mass M1, acceleration A1. And what is the Fk value? Already we have mu M2g. See here, Fk value. Okay. Fk is mu m2g. From this equation, A1 we are finding. A1 equal to, we have mu m2g upon m1. Now you please answer, this acceleration is a dependent on time or independent on time?
Independent of time.
This independent on time means it is constant with the time or changes with the time?
Constant with
Right.
time.
So this acceleration A1 is constant with the time, and the time is a t less than t naught or t greater than t naught? T greater than t naught. So coming to graphical section. Now here I'm taking t greater than t naught. Okay, now this part, t greater than t naught. So if a t greater than t naught, so up to t naught, m1, m2, they are moving together. Now after t greater than t naught, so how m1 block is moving? Constant acceleration.
Parallel to x-axis.
Okay, parallel to x-axis. It is A1. Okay. Completed.
Sir, can you show that diagram?
So it's a diagram only, na? Block diagram, or this part you're asking?
Thank you, sir.
Yeah. Right now, next M2. Now, in the case of M2 block, you please answer. What is the dynamic equation?
F minus K. Sorry.
F minus Fk. So it is Fk, sorry. It's not F2. It is Fk. So in the case of M2 block, so dynamic equation is F minus Fk. Now resultant force means mass into acceleration. Mass is M2, acceleration A2, and A2 value we are finding. Applied force is a Kt minus, what is the kinetic frictional force? Already we have mu m2g, kinetic frictional force. So mu m2g. So you divide with m2 on both sides, dividing with m2. So this value becomes A2 equal to, this value becomes K upon m2 t. We are dividing with the m2, becomes mu g. Now you refer this equation. So in the graph, you please answer acceleration taken on x-axis, on y-axis, this acceleration. This acceleration value we are taking on y-axis, and time we are taking on x-axis. So therefore it is in the form of y equal to mx plus c. That means what is the nature of the graph? Straight line or the curve?
Straight line.
Straight line not passing through origin.
Not passing through origin. Perfect. Then what is the slope of this straight line?
So K upon M2.
K upon M2. So in the first case also here straight line. But for this straight line, what is the slope? K upon M1 plus M2. Okay. Now this slope K upon M1 plus M2 is greater. This slope K upon M2 is greater. Initially, what is the slope we got it? Initial slope is K upon M1 plus M2, we got it. Now you please answer.
Second one is greater.
Now this slope is greater or smaller?
Greater.
So here final, already we completed A1 graph. So if a time greater than T naught, already M1 block acceleration we completed. That is constant with the time, so parallel to time axis. But in the case of M2 block, so what is the acceleration? Dependent on time or independent on time?
So dependent on time.
Dependent on time. And what is the nature of the graph?
So like
Straight line
graph not passing through origin.
And so here straight line not passing through origin, correct? But the straight line is having greater slope with respect to previous. So greater slope. Okay, that means how to draw it. I'm drawing the graph. You have to say that is correct or not. This one.
Correct, sir.
Why? Because It is having greater slope with respect to previous one or not?
Yes, sir. It has a greater slope.
It is acceleration into. Therefore, it is the acceleration versus time graph. So up to the time t naught, they are moving together with the common acceleration. And t greater than t naught, they are moving separately. Now we have individual accelerations. Is it clear, the whole question?
Yes, sir.
So write down here also, what is the slope of this straight line?
So K upon M2.
K upon M2. Now write down. So type 3. Now.
Sir, can you show that M2 part? Thank you, sir.
Completed?
Yes, sir.
Sir, can you show the diagram once again? Thank you, sir.
So write down type 3. In time 3, I'm taking both surfaces rough. No, it is rough surface. So this block mass 5 kg. Then after, this block mass 2 kg. So here, for this surface, mu equal to, for example, 0.2. And this also rough surface, mu equal to 0.5. And it is applied force F. Applied force F. So if this is the question, so how to deal? So how to deal the question? You please answer. Between 2 kg block and a 5 kg block, between them, what is the value of Fs maximum? Between 2 kg block, 0.5 into 2 kg weight or 5 kg weight?
2 kg.
So 20. It is nothing but 10 newtons, correct? In the same way here, now between 5 kg block and the ground, between 5 kg block and the ground, so how to find Fs maximum?
0.2 into 50.
0.2 into, please.
5 to 10. 50.
15 Newton, 20 Newton, 17 Newton. 70.
70 also, yeah. 70.
Why? Because so on this rough surface, both weights are acting. Okay.
Yes.
Therefore, Fs maximum equal to 0.2 into 70 means Fs maximum equal to 14 newtons. But same thing we have to start with. Okay, for example, they are moving with a common acceleration, for example. Okay, the same assumption we have to make. So assume that. Okay, first of all, here the two blocks, they started moving or not? The two blocks, they started moving or not? Okay, you please answer. So how to know the two blocks, they started moving or not? You please answer. If this applied a force, so here the two blocks, they have to move. Okay, they are moving together or moving separately, but to start the motion, this applied force, it has to overcome this frictional force value.
Yes, sir.
This applied force, it has to overcome this bottommost frictional
So
value.
the bottommost, that is 14 Newton wala friction.
14 Newton. Okay, that means here you please answer. The first point in this question is, if applied force less than 14 Newton, if applied force less than 14 Newton, then what will be happened?
Body is at rest.
So both blocks less than or equal to also, correct? Even though F exactly equal to 14 Newton, they started moving or ready to move.
Ready to move.
Ready to move. So if F less than or equal to 14 Newton, both blocks at rest position. So A1 equal to 0 and A2 equal to 0. Then after, I'm taking F greater than 14 Newton. I'm taking F greater than 14 Newton. No, you please answer. So if F greater than 14 Newton, the block's motion will be started or not?
So started.
So if started immediately, what is the assumption we have to make?
So same
Common
acceleration.
Correct. So if F greater than 14 Newton, so let us assume that both blocks move together. Both blocks move together with common acceleration. Both blocks, they move together with a common acceleration. But how to find this common acceleration?
F upon m1 plus m2.
You're finding this common acceleration. Yeah, any other one?
So F upon total mass.
F upon total mass. Any more options from others? That is wrong. F upon m1 plus m2 is wrong. Any
So
more options?
from the two equations equate A.
No, just think logically here. From this figure, you think logically. Otherwise here, so both blocks are moving together, correct? Both blocks are moving together. So I'm taking both blocks as a single block. I'm taking here both blocks as a single block. And what is the mass of this single block?
7 kg.
7 kg. On this 7 kg, totally how much applied force acting?
F.
This F value is greater than 14 Newton. Okay, this F value greater than 14 Newton, and they are moving together with the same acceleration. They are moving together with the same acceleration. But on this 7 kg single block, there is no friction.
So there is friction.
Which friction? Which friction? Ground wall
So the
friction or between the blocks?
Ground wala, ground wala.
Ground
Correct.
friction.
So therefore, it is 14 Newtons. Now you please answer finally.
F minus 14 upon 7.
Perfect. So how to find a common acceleration? That is F minus 14 upon in denominator sum of the masses. That is
That's 7
kg. Is the logic clear enough?
Plus.
Is it clear? So in the previous question, that is smooth surface. In the previous questions, it is smooth surface. Then what is the only applied force is applied force. Applied force upon sum of the masses. But in this case, they are moving together with a common acceleration. Okay, they are moving together with the common accelerations. We are taking as a single block. Okay, we are taking as a single block. On the single block, what is the total applied force? That is F. But they are moving together means on the single block. So which friction is acting? So ground wall friction force acting. So therefore, this common acceleration is F minus 14 upon sum of the masses. Okay?
Sir, you have
please.
taken 14 Newton because that is the value of Fx max.
So why? Because here, so once the block started moving, now what type of friction will be present here? Static or kinetic?
Kinetic.
But even the kinetic, what is the formula we have to follow? Mu into N.
Mu m1g.
And what is mu value here? Mu value, mu s value, both are same or not?
Yes.
Okay, so it is Fk, frankly speaking, it is Fk, but how to find Fk? If we follow same procedure, we get 14 Newton, correct?
Okay, sir. Okay, got it.
So,
Please.
so to find Fk here, we'll use the formula mu equal to mu mg, right? And m is
Correct.
equal to like 7 plus, 2 plus 5.
2 plus 5.
That's 7, right?
Correct.
Okay,
correct.
sir. Thank you.
No, so here the two blocks are moving together with a common acceleration. correct? But what is the common acceleration? What is the maximum value of common acceleration? What is the maximum value of common
A max
acceleration?
equal F max minus 14 upon 7.
Minus 14 upon 7.
So in this case here, you think they're moving together. They're moving together with the common acceleration. So they're moving together with the common acceleration means, no, this friction is helping them to move together, or this friction is helping them to move together. Which friction is helping them to move together?
So 10 Newton
1
wala.
upon.
Means between 2
So 10
kg and 5
Newton one.
kg?
Yes.
Correct. Right down. Here, static frictional force, Fs between 2 kg block and 5 kg block helps them to move together with same acceleration. Is the point clear? So here, what is the assumption we are making? Both blocks are moving together, but to move together, which friction helps? Now this friction helps to move together, or this friction helps to move together. So this friction helps to move together. So therefore, this Fs value is less than or equal to Fs maximum. Therefore, Fs less than or equal to, and what is the Fs maximum value is? 10 Newton or 14 Newton?
UMG.
That is 10 Newton or 14 Newton? 10 Newton.
So
Less
10
than or
Newton.
equal to 10 Newton. So therefore here, so this frictional force between 2 kg block and 5 kg block helps them to move with same acceleration. So to find this Fs value, so 2 kg block we have to consider, or 5 kg block we have to consider.
So could you
To
please
find-
repeat?
To find this Fs value, this is static friction. So we have to consider 2 kg block or 5 kg block.
2 kg block.
2 kg block.
kg block. By 2 kg block.
Sir, because that is the frictional force which helps them to move together.
In the case of 2 kg block, what is the only driving force? In the case of 2 kg block, what is the only driving force?
Fs.
Frictional force.
Okay, just only 5 minutes. The class up to 8 to 10 or 8 to 10:30? The class.
8 to 10.
10
Okay,
o'clock.
8 to 10.
Okay, just only 5 minutes. Okay. Let them complete this question. Okay. So in the case of 2 kg block, what is the only driving force? What is the only driving force?
Fx max.
Frictional
F
force.
max.
Fs. So
Frictional
that's why
force.
here to find Fs, I'm taking only 2 kg block, the top one. In the case of 2 kg block, they're moving together with a common acceleration. In the case of 2 kg block, what is the only driving force is static friction. But what is the direction of static friction, forward or backward?
Forward.
Forward. Okay. Then in the case of 2 kg block, keep the mic off. In the case of 2 kg block, what is the dynamic equation is? Fs.
Fs.
Then after, net force means mass into acceleration. Mass is a 2 kg block. I want to find a maximum common acceleration. To find a maximum common acceleration, so here in the place of Fs, what we have to take?
Fs max.
Fs max.
Fs max. I want to find a maximum common acceleration. We have to find Fs max. Therefore, 2 into, we are finding maximum common acceleration
So
equal
5
to,
meter per second square.
what is the Fs maximum? Already we have 10 Newton.
10 Newton.
Therefore, this maximum common acceleration. Therefore, maximum common acceleration equal to 5 meter per second square. Okay. Now listen here. Now I want to find, see, If F greater than 14 Newton, what is the first assumption we are making? They're moving together with a common acceleration, and we got maximum common acceleration. Now here the question is, up to what maximum force they move together? To find this maximum force, what we have to consider? So general common acceleration or maximum common acceleration? What we have?
Maximum common acceleration.
So to find F maximum, we have to consider maximum common acceleration, right? To find maximum applied force up to which they move together, we have to consider, so which acceleration we have to consider? Maximum common acceleration. Okay, so how to find this F maximum? You write down what is the dynamic equation. In this case, what is the dynamic equation?
F minus 14.
So F minus 14, but in the place of F, I'm writing F maximum. F maximum minus 14 is a dynamic equation equal to resultant force. Resultant force means mass into acceleration. What is the mass here? 7 kg block.
7 into 5.
7 into, so maximum common acceleration. Maximum common acceleration. It is only 2 minutes over. Therefore, F maximum minus 14 equal to 7 into, what is the maximum common acceleration? We got it. 5. Therefore, what is the value of F maximum is?
49.
49 newtons. Okay, that means here they move together. So here F greater than 14 Newton, from 14 Newton up to 49 Newton. From 14 Newton up to 49 Newton. So how they move? So if applied force less than 14 Newton, both blocks at rest position. Then from 14 Newton onwards, up to 49 Newtons, how they move?
They move
It's
together.
common acceleration.
So therefore, in this case, if applied force in between 14 Newton and up to 49 Newton, they move together. Is it clear? If they move together, then what is the common acceleration formula? What is the common acceleration formula in this range? What is the common acceleration formula?
F minus 14 by 7.
F minus 14 by 7. And what about this force? This force in between 14 to
49.
So if this is the case, now between the blocks, what is the nature of the force? Between the blocks, what is the nature of the force? Static or kinetic?
Static.
So
Kinetic.
between the blocks, static or kinetic? Static. While they are moving together, the two blocks, they are moving together, there is no relative motion. So between the blocks, static frictional force is present. But between ground and 5 kg block, they are moving together. Means between the blocks, what is the nature of friction? Static. But between the ground and 5 kg block,
Kinetic.
block, kinetic. Yeah, right now. So between ground and 5 kg block, kinetic frictional force is present. Finally, if applied force greater than 14 Newton, so how they move? Together or separately? If applied force greater,
Separately.
they move separately with different accelerations. Now, what is the relative motion between them? Present or not present?
Present.
Present. If relative motion is present, so here
Kinetic frictional force.
everywhere between the blocks or between the ground and the block, so what type of frictional force will be present? Kinetic frictional force is present everywhere. So this is the procedure. So let us continue in the next lecture. Okay. So just we have 5 more questions, then this friction part will be over. Okay.
Thank you, sir. Bye, sir.